project that I've seen that actually really used components of variation, so it was really cool. So anyway,
wow.
I digress. So we were two measurements.
Oh, here, let me show you this. This is what we had as guidance.
Yeah. Select two key measurements. Well, for our division, and since we've got Robert on our division, ATS, air test setting is a huge is something that we measure in all of our facilities, and it's we measure it because it's a specification set by the customer, but we also measure it as a means to improve. So there's a lot of components of variation, if you will, to that air test setting. Both process, measurement system, and components, and that all really affects that end setting. And so, it's a setting, it's a measurement that we use, and it's one, to meet a specification, but two, it's also how we measure our improvement.
Did I capture that right, Rochelle?
Hang on, I just wanted to say hi and check in, and it looks like everything's going well. I just didn't want to interrupt Rochelle, so I'll go back to the main room, and we'll see you in a few.
Okay, thanks. So why measure? So means to improve. What to measure? Air test setting. Measure. Yep. It's a tricky son of a gun. I don't know, Robert, do you have anything else to add? I know you've been doing a lot of stuff with TK lately.
Yeah. I think our biggest thing with TK is, component level variation.
What is TK?
Thermo King.
Thermo what?
Yeah.
Thermo King is a customer of ours.
Oh, the customer. Okay, I thought it was a type of testing. Sorry.
No.
So this air test setting, what is that?
It's separated from this. I'm sorry, from the TK side of it. Air test setting, we make thermal expansion valves, and there's the air test setting, which is the outlet pressure of the valve with a given inlet pressure, which equates to ultimately the I'm drawing a blank on that term, Rochelle. Superheat.
Superheat curve, yes.
Yes, this superheat performance for the valve.
Okay.
So these go into air conditioners, and what it does is it tells the valve when to open and when to close, and it's mechanical, not electrical. So when you get pressure under the diaphragm, based on the setting, it'll open the valve, and then when that pressure drops, the valve closes. So there's two diaphragms, and it's
so having that set very correctly will, having it not set correctly will cause performance issues in the system, right?
Yes.
Correct.
And our customer spec is very tight, and they want to tighten it even more. So we're challenging them, saying, is it really necessary?
Okay.
So that's
so for the why measure question, it is, I mean, you guys are saying do you measure every one of these to make sure it's calibrated, or do you measure them to make sure the process is constructing these in a way that they perform right?
Yes, the customer is it's TK was a different issue. You can take that off. But so we set every single one to 0.6 psi through it's called a calibrator, and it goes in there and it blows air across the valve, and we set it. And then what we do is we sample. So we take 3 pieces every hour, and then we run across what we call our manual calibrator just to check. It's a process that we're trying to get rid of. And this is the improvement piece.
Yeah.
So it's specs set by the customer, but what we do is we really want to get rid of the secondary testing because it's laborious. There's a lot of error in it. And so what we do is we take those 3 pieces and we put them on a separate machine. So we add variation, and then we measure them, and we chart SPC. And then if we have out of control points, we will go back and reset the, so we're earling, so then we'll go back and we'll reset the calibrator based on some criteria. Now, this was Marty's black belt project and it's still ongoing. So again, it's measuring the spec because it's customer spec, but then it's also, we're using it to improve.
And I think also, whoops. You kicked us out.
Love that forced return.
Hey, everybody, welcome back. I'm glad you could all be on time. So let's go ahead and start with team 3, actually, session 3. If you'd like to have some platform time here, 30 seconds to a minute out brief. What did you discuss in your group? I heard a lot about what was it, air test monitoring when I stopped in for a second. But Rochelle,
Claire,
can you?
Claire, we can't hear. Claire's our spokesperson, Frank, and we can't hear her right
Oh,
now.
Claire. Okay.
Okay, I'm not the spokesperson. Thank you for trying to delegate that to me, Bill, but I was just scribing here. But what I heard was there was a lot of things about why they're measuring particular elements, and it's around spec set by the customer, and then also going forward, I believe reading between the lines to understand whether or not the current product meets some tighter future spec that the customer wants to have in place. They're measuring air test setting, it's an outlet pressure, it's a mechanical measure of mechanical valve performance. They got it set to a specific reading, 0.6, and they have some manual testing that's taking a lot of time and has error in. So they're trying to move away from that right now. So I'm going to hand off to the rest of the team there. Anything you want to add?
I think a third reason on why measure, Claire, was to calibrate.
Yeah, and I like that. I like that discussion. It kind of shows that measurements today, or a measurement system today, may not be good enough for tomorrow. That's great. Thank you, Team 3. Team 2.
Yeah, thank you, Frank. I'll be speaking for Team 2.
All right, thanks, Austin.
We started off talking about measuring the different places where data